Wonderful to see you all. I'm alone in the classroom with Jack, Ruby, and her friend Sophia. I'd much rather have a class full of people. I'm sure you guys are like, yeah,
Would you though? Would you?
we can TikTok. Does everyone want to see Ruby? Ruby, come up here and say hello to everyone. Come on.
No, thank you.
Okay, she won't come up. There's Jack though, so I can at least talk to someone when I'm doing this. All right. So what we're going to do first is, I know your homework you had 1 through 22 dealing with rate and, wind and current problems. And that's due, I'd like it to be due obviously today, but I'm sure a lot of you have been on break, especially with this stressful week. So your homework didn't get done. So we're giving you till Wednesday to turn in that assignment. It has to be turned in at school, or if you're unable to get here, please, take a picture of it and TikTok me. Kidding. Email it to me. That would be great. But make sure I can read it in Trenton. Not too much of that wonderful website that you just copy everything from. Look, see, I'm looking at you like you're here and I can see you, but it's the ghost of Trenton. All right, anyway, so let's review, especially for the people who were sick during the week before spring break. Let's review what we were doing again, because we're trying to wrap up chapter 9. There will be a test sometime this week. I'm not sure how we're going to administrate this so that there's not a ton of cheating, but remember what I say about cheating. That's all on you. You can fake yourself all day long, but when it's really time to learn to know the material and show me that you know it, if you're not going to be able to do it on the test in front of me versus at home, we know that you haven't been really applying yourself. Jack, put your phone up. All right, so let's talk about a system of equations is 2 equations with 2 variables. So we first learned how to solve a system of equations by graphing. And we solved each of these for y. And we went to our graph paper. This is our y-intercept. Our slope is 1 over 1, so that's rise over run, down 1 over 1, down 1 over 1, and this was our line. Same here, our y-intercept. This time our graph is up, our slope is 1 over 1. They're not parallel. I'm going to go up 1 over 1, up 1 over 1. Here my slope's negative, it's going down at the right. Here my slope's positive, it's going up at the right. Here is my point of intersection. So the whole idea, remember, is we're solving. That means to find the solution, the ordered pair that satisfies both of these equations, which of course is 0, 3. This point right here. Remember, there are 3 types of situations that occur. We either have 2 lines that intersect at a point and there's one solution. We have the same line and there's an infinite number of solutions. Jack? Or the third situation is where we have 2 lines that are parallel and there are no solutions. Quickly, if the 2 lines are parallel, slopes are the same. The y-intercepts are different. If we have an infinite number of solutions, we have the same slope and the same y-intercept because it's the same line. 3 situations. 1 solution, infinite, no solution. On tests, sometimes you don't have graph paper. So we learned math methods to help us solve these. The first method we learned was called this is our math method. Those are our graphing method. So the first one we learned was called substitution. So if I have 2 equations, I want to solve one of these equations for a variable. This one is, thank goodness. I'm going to take this side and substitute it into the other equation for that variable. So that means x, which is that guy, plus x plus 3 equals 3. X plus x is 2x plus 3 equals 3. I'm solving for x. Subtract 3 on both sides. 2x equals 0. And everyone in the audience better be like, oh yeah, that's 0.
X equals 2.
No, that does exist. Remember, 0 in the numerator is fine. So that means, same thing, I'm looking for an ordered pair, a solution to this system of equations. So I'm going to have to find an ordered pair. Has an x value and a y value. Now I'm going to take this value and substitute it back in here. 0 plus 3 equals y. 3 is y. Please notice these were the exact same equations. We got the exact same answer. If I do it by graphing, if I do it by math, I'm going to get the exact same answer. And if I don't, you have a problem. The second method we learned was called elimination. Here, we're going to eliminate a variable if the coefficients are opposites of each other. So a quick example. Sorry. I don't have Grace here with her book right in front of me, unfortunately. I know you miss me, Grace. X plus y equals 7, and x minus y equals 3. Here I have two variables whose coefficient, that's the number in front of the variable, are opposites of each other. When I add them together, because they're opposites of each other, property of opposites, that goes to 0, it goes away. So that gives me 2x, x plus x is 2x, these two go to 0, equals 10, divided by 2, we find x is 5. Again, I have a system of equations, so I'm looking for an ordered pair that is going to give me the solution to these. I take this 5, and I can substitute it right back in here. 5 plus y equals 7. Subtract 5 on both sides. Y is 2. So my answer, my solution, 5, 2. Using the elimination method. When we introduced this, we said, hey, now things become easier with word problems. We can now, instead of only using one variable, we can use two variables, x and y. But when we use two variables, we have to have two equations. So what I want you to do really quick is turn to page, had it, 434. I want you to turn to page 434 right now. While I'm erasing, turn to page 434. On page 434, I want to review how to use a system of equations to solve word problems. So we're going to work on 10, 13, and 20. 10, 13, and 20. Aiden, we're going to use 5 steps on this, buddy. 5. I know you hate 5 steps. 10, 13, and 20. I hate 5 steps. I want you to stop the video, and I want you to go work on number 10 right now. When you get to a point you think you have it, or if you're stuck, turn me back on, and I'm going to be explaining number 10. Stop the video.
I think the 5 steps is so lame. It is.
Ruby doesn't like 5 steps, but that's okay.
What checking? Like. No.
Yeah, we don't want to do that.
No need for that.
So on page 434, number 10, 3 pens and 2 notebooks cost $8.25. 2 pens and 3 notebooks cost $8. How much would 2 pens and 2 notebooks cost? So,
That's a tough one. Just kidding.
we're going to use X for pens, Y for notebooks. This is step 1. Got to have step 1. Got to tell me what X and Y are representing. If you do not tell me what they stand for, I get to mark off on your test. The first equation, 3 pens and 2 notebooks equal $8.25. The second equation, 2 pens and 3 notebooks cost $8. Step 2. You can decide what method you'd like to use. Personally, I would use elimination on this. If you're asking, the coefficients of neither variable are opposites of each other. The coefficients of neither variable are opposite of each other. What can I do to make that happen? Where the coefficients of either one of these are opposites of each other. Sophia, put your phone down. You can either make the x's opposites of each other or the y's opposites of each other. Jack, which one do you want to do? Okay, it's taking too long.
X's.
All right, Ruby, thank you. We'll make the x's opposites of each other. So 3 and 2, how do I make them opposites of each other? Remember, as long as I multiply the equation by a number, and I multiply the entire equation by the same number, it's legal. So I'm going to make them 6 and the opposite of 6. So I'm going to multiply this guy by a 2 and this guy by a -3. Wait, you can multiply both equations by some number? Yes, I can. Both equations by some number. This becomes 6x plus 4y equals 2 times $8.25. Sophia, how much money is that?
Oh no. Some number.
Money, I don't care about money. My mom gives it to me.
Alright.
The second equation, I'm going to multiply by a -3. And I can do that as long as I divide and multiply everybody by a -3. This becomes -6x minus 9y. -3 times 8, -24. Okay? So as long as I multiply the equation, everybody in the equation by this 2, that's legal. If I multiply this guy by a -3, it's legal.